In this video, I would like to demonstrate how to do a trade-off between the presence of bass in your signal and the presence of reverberation in your signal. I've already got a three-way system which I previously captured, and in this system I've gone to the chirp config or the setup parameters page, which is the middle icon on the right there. And we're now playing with the trim point. And you can see with the trim point maximized, there's a very large amount of reverberation in this signal. And there's also a large amount of low frequency power in the signal. The trim point trades off between the presence of reverberation and low frequency power. So if I take this trim point all the way to the left, I can see that the presence of low frequency power has disappeared, and so has the reverberation. As I move through, more and more bass frequency power is present and resolved, and more reverberation is introduced. This highlights the importance of taking your speakers into a large room or outdoors where you can get a large distance between the first reflection or a reflective surface and your microphone and speaker. And in my situation, I'm indoors. I have a very short distance from the speaker to the wall, which would be the first reflection point. And if I was to go to the time domain by clicking on from DFT to group to time and changing the x-axis to a logarithmic range, I can now see the signal, and I can see that the trim point is roughly at 30 milliseconds. I can click on this to change the trim point if I don't want to do it by moving the slider. I can also see that my first reflections appear to be coming in at roughly 2 milliseconds. You can see the peak of this blue line here. And if I were to use a 2 millisecond trade-off, then I could work out the lowest frequency that would be present in my signal, and that would be 1 divided by 2 milliseconds, which would be roughly 500 hertz. If I was to go to the frequency domain again, I can see here that at roughly 500 hertz is where it seems to go very smooth, and the signal seems to start to disappear, which confirms the computation. For this signal, I'm going to set a trim point which includes reverberation out at around 30 milliseconds. So there's a certain amount of reverberation in this signal, but there's a large amount of bass down to around 33 hertz. That might be a bit excessive for this speaker that I'm using, so I might wind that up to even wind that down to around 20 milliseconds. And that is how you work out how to trade off between the presence of bass frequencies and reverberation.